It's John Black, super chemist. Well, time doesn't slow down because time isn't a thing. Okay, it's an adjective. All right. So if you're standing still, right, and you're not moving through space, and let's say you have these are two synapses in your brain, right? The thing you need to understand is all physics uses photons as force carriers and information carriers. So how do your synapses talk to each other in your brain? Your billions of synapses probably. How are they talking to each other? They're throwing photons at each other. That's how they talk, right? Now, if you're standing still, which nobody is, right? If you watch my "Can You Really Stand Still" video, you'll know what I'm talking. You are not standing still. This isn't you, but we pretend you are. If your relative standing still, you would have a clock. You would have a synapses. You, you would have synapses where the photon only had to travel that little bit of distance, right? But what if you started moving? What if your synapses is this, and then you start moving, and now this is more of a distance. Look, it's this blue line now. That blue line is now how long it takes for your synapses to talk to each other. Time doesn't slow down. It's just information takes longer to get to the information taker. You know, the one that if this guy throws out a photon, look, it takes longer to get to the other synapses so you can think about what he said. You know. Now this all this, and then you can make this right triangle. See the red, the blue, and the orange. This would be what time would be if you just stood still, right? That would be like a second, say. Here, though, it's a ratio. See, and if time was a dimension that you actually went into, and we take one of the, we can graph it that way. We can take off one of the spatial dimensions and replace it with the time dimension, and get this. And if we did this just with spatial dimensions, we can do this. Okay? But see, just because it works with spatial dimensions and because we can take off a spatial dimension and replace it with the time dimension, it doesn't mean the time dimension exists. Okay? Time is just a result. Okay? A result of moving and making this line longer, the distance in between. See, Einstein's postulate has a heads and a tails, right? Just like a quarter, just like an up and a down. You can't have one without the other, okay? The heads part is, hey, guess what? Light always travels at 186,000 miles per second, no matter what. Always does that, you know what I mean? No matter how fast you're going. Even if you're going half the speed of light, in your frame of reference, light's still going. How does it do that? Well, look at this. Let's say this is a hand on a clock, right? You know it's going to rotate clockwise, right? Something's attached to it down here, and it tells it when to move. You know what I mean? When it's the next minute or the next second or however it ticks, how often it ticks, right? So if you're just standing still, like right up here, right? The photons, it's like we said, all force carriers and information carriers are transmitted by photons, right? Whether it's atoms, whether it's synapses, whether it's your electronics, parts in your electronics thing, they all work with photons. So he sends a photon, the thing that's attached to this tells it to move, right? But it doesn't just automatically move like magic. No, one atom moves, and it sends a photon to the next one. And then it moves, and it sends a photon to the next one. It moves and sends a photon, and so on and so forth. But look here when you're moving. Now, second to second, your thing is longer. Then it's longer here, and then it's longer here. Right? This path is a lot longer than this path, right? So and look, you can see too, even the little triangles, all these little triangles, if this mechanical clock, and this synapses in your brain was in the same frame, meaning moving at the same constant velocity, right? They'd get the same time dilation, and they would get the same triangle. They're all right triangles, right? But they would be all proportional to each other, because this blue line is going to be the same in all these frames, right? Whether you do it second for second, or you do it over the entire 5 seconds or whatever, the entire 4 seconds, 3 seconds, whatever. This triangle will always pop up at this velocity, because you need to get this, because time is measured by this distance. This distance relative to the red standing still clock, right? So you're not going into another dimension. So you're not going into some kind of magical new other dimension. You know what I mean? It's a mathematical construct, right? Mathematical constructs are imaginary. Okay, they're just on paper in your mind. Okay, they're math descriptions, right? This is a math description. The dimension is an adjective, like big, red, small, 6 inches long. That's an adjective. You can't pick that up. That's not a thing. It's not a, you know what I mean? So, yeah. There is no fourth. There's only three spatial dimensions. I'm going to stop calling them space-time too, because they're not space-time dimensions. They're space dimensions. You just happen to go through them. Time slows down because all the information carriers have longer distance to travel. So, duh. Obviously, if my brain takes twice as long to, give all the information, transmit it through my brain, then yeah, my thinking's gonna slow down, right? All physics uses photons as photon carriers or information carriers to do any physics. All physics relies on this thing. The tails part of that was this length dictates time. This length dictates time. Here, where you're standing still, let's say a second. Well, this length is your time. This, the longer it is, the more time dilated you are, the more faster you're moving, because you're moving faster. It's the distance. Time is this distance, right? This distance here is, say, 1 second. This distance here is also 1 second. It's always a second. Yeah. It's just things slow down, not because you're going into another dimension, but because all the information is just getting to you. It's like slowing down a movie thing projector that's going, right? You slow it down so that you get the information less. You get the information slower. Yeah, everything's going to slow down, right? But if you turn it up so that you get the information faster, guess what? The video looks regular, and then it starts looking like it's going super fast. So hard to understand. You're not going into no other dimension, okay? And what does this mean? It means all synapses, all electronics, all forces like acceleration, right? Your heart, all metabolic processes, all your thoughts, everything relies on this idea, right, that information carriers and force carriers are transmitted by photons. And photons move at 186,000 miles per second. So the flip side of that means the longer this distance is, meaning the more you move through space, the longer this distance is, the longer it takes to get your information, transmitted. So things are going to slow down, just like if you slow down a movie projector. Yeah, it's going to slow down. Slow down the information, yeah, then everything slows down in that universe, meaning the movie. You speed up the flow of information by turning up the movie projector. Yeah, guess what? The movie goes faster. Yeah, but the movie projector doesn't go into some fourth dimension. Okay, all right. It's all about remember, all these triangles are all proportional. They all go by. And I know I spelled a lot of wrong things here, like Pythagorean theorem. There's a lot of more misspellings in this video than usual, but yeah, everything always lines up with this Pythagorean. All these things have photons as force carriers or information carriers that line up with this Pythagorean theorem. And if everyone is moving, your electronics, your synapses, your mechanical things and mechanical clocks, then they will all have the same blue line. So they will have the same, they're all transmitting data or information to forces at the same slow rate. You know what I mean? And that's why you get time dilation. Okay, it's not going through. It's not going through a magical dimension. Okay, there's no magical dimension. It's a mathematical construct, right? So it is true. Okay, I'm going to stop saying it though because these people are taking analogies and acting like they're real. Mathematical constructs are not real. Okay, they are by definition mathematical constructs. They're imaginary. They're physics adjectives like red. They're describing something like length, height. Height isn't a dimension. It's a description. It's an adjective. You can't go to adjective universes. You can't go to 2D universes. This is all insane. This isn't crazy. All right. This is time dilation. Okay. There is no fourth dimension. All right. It just works out mathematically that if we didn't have one of our dimensions and we replaced it with a fake time dimension, all the math checks out. But we can see it's not really. I mean, if we use our common sense, we can see it's really because we're just moving, and it takes the photons longer to transmit information. That's why things are slowing down. It's not because we're going into some kind of other dimension. Like, come on. Like, use some common sense. Yeah. And this idea that you can have unlimited dimensions, higher dimensions, this reeks of gender theory. Yeah, you can have unlimited genders, unlimited. Just like you can have unlimited higher dimensions. Just unlimited. You can just have unlimited. That's all right. As long as you feel that you could, even though it's imaginary, you can still believe. If you believe in imaginary stuff, then it can be real. That's what higher dimensions are.